In this video, we are going to study rectangular signal. So let us start the representation of rectangular signal in continuous time domain, which is denoted as CT signal. In this domain, we represent signal as x of t, and the equation of rectangular signal is given as a rect of small t divided by capital T. In this equation, this a is the amplitude of signal and capital T is the width of rectangle. So if we plot this signal, it is represented as x-axis as time and y-axis, which is amplitude, as x of t. As the width of rectangle is t, this signal starts at coordinate minus t by 2 and end at plus t by 2, and it has a rectangular waveform between these two coordinates with the amplitude equal to a. So this is how we represent the rectangular signal in CT domain. Remember, here whenever we are representing this signal, here this capital T is the width of rectangle. So always plot the coordinates as minus t by 2 to plus t by 2, and at center we have the origin of the signal axis. Similarly, to represent rectangular signal in discrete domain, we have the equation as x of n equal to a rect of small n divided by capital N. Here also this a represents the amplitude and capital N represents the width, and the signal is drawn as x-axis will be n, y-axis, which is amplitude, will be denoted as x of n, and this signal will now start at minus n by 2 to plus n by 2, and as we know, this discrete signal is always drawn on a vertical lines. So here we will have multiple samples at integer values. So this is origin, so 1, 2 and so on up to n by 2. Similarly, in the negative direction also it will be minus 1, minus 2 up to minus n by 2. So this is how we represent the discrete version of rectangular signal. Now let us take a simple example. Let's say we are supposed to draw a signal x of t equal to, let's say, 2 rect of t by 6. So in order to draw this signal, first let us write the equation for the rectangular signal, which is a rect of t by capital T. In this equation, if we compare both the equations, the amplitude a is 2 and the width of signal is 6. Therefore, we can draw this signal as x-axis will be time because it is CT equation, y-axis is amplitude, x of t. We have the origin. Now here the capital T is 6. Therefore, the signal will start at minus t by 2, which is nothing but minus 3 to plus 3. Therefore, total width of signal becomes 6. And we are going to draw a rectangular pulse in this way with the amplitude of signal as 2, which is capital A. So this is how we can sketch the rectangular signal for the given equation.